Thanks Adriana and Chris for showing us how to find the internal moments in both the real and the virtual frame. So my name's Kirsten, and I'm going to kind of put what they did together to determine the horizontal displacement at point C. So we're going to use this equation right there. You can find that in section 9.5 of the book, and I'm just kind of going to summarize what they have to define the different variables that are in there. The one, which looks kind of insignificant out there, but it's really important to the theory behind where this equation came from. So the one stands for the external virtual unit load that's acting on the beam or the frame in the direction of delta. So that's what you saw Chris sticking out there at point C. That's where that's coming from. The delta, of course, is the horizontal displacement that we're solving for. The little m is coming from the virtual internal load forces. It's important to know that's virtual, and the big M is from the real. So the big M is the internal loadings that Adriana solved for in the real frame. And E and I, of course, the E is the modulus of elasticity of the material, and the I is the moment of inertia of the cross-sectional area. So those, that product remains constant throughout this entire problem. So that's not really factoring into it, but as we go through our calculations, we still need to keep the EI in there. So I'm going to come over here and draw the frame just so you can see where we get these three pieces from. So our first, we split it up into the three pieces because we solved for three different sets of internal loadings. Because of the spots that the loads are placed on the frame, the moments are going to change at different points in the frame. So you're going to have a certain internal moment here, another one here, and another one here. So that's where these are coming from. So the first one is going to be from 0 to 6, which is this piece right here. And 6 is the length of that piece, so that's where we're getting those numbers. And 0 is our small m. That's what Chris had determined for the internal loading, or internal moment for the virtual frame. This is what Adriana found, the 600 x1 plus the 1200, that's the internal loading for the real frame, of course over the EI. The 0 to 5 is going to be for this piece, right here. And 1x2 is what Chris found to be for the internal loading. 4800 is what Adriana found for the real internal moment over the EI. And then the 0 to 5 for the last piece. And this is, Chris found 5 plus 1x3 for the internal moment for the virtual frame. Adriana, of course, found 4800 plus 800x3 for the internal moment for the real frame. So now that we have all our numbers plugged in, it becomes pretty simple to just kind of do your basic integration. You're going to multiply everything through. Of course, this term is going to completely go away because of this 0 here. So we'll set that equal to 0, which we have down here. This we're going to multiply through, and then that becomes a quadratic equation, which is right here. Come down here, we're going to integrate the two pieces. So you can work through that if you want. It's just 4800 x2 squared over 2EI. And of course, you're going to take that from 0 to 5. You have right here 24,000 x3 over EI plus the 8800 x3 squared over 2EI plus 800 x3 cubed over 3EI. So those are going to go from your limits 0 to 5. When you plug the limits in, you have your four different pieces, and those are going to sum up to 323,333 pounds feet cubed over EI. That's your ending equation. So if you need any more help or you want to reference some more stuff, look at section 9-5 in the book. Thanks.